Hello, and welcome to a tutorial on factoring polynomials using the greatest common factor, otherwise known as the GCF method. The GCF method for factoring is the reverse of the distributive property shown at left. If we multiply 3 times 5x plus 2, we get 15x plus 6. But factoring 15x plus 6 brings us back to the multiplication problem 3 times 5x plus 2. How do we factor using the GCF method? It's easy. I'll show you how. Let's take an example. Factor 2x squared y plus 4xy. Each term has factors, and we want to break down each term into its product of factors and look for common factors. Between 2x squared y and 4xy, 2 is a common factor, x is a common factor, and y is a common factor. Multiply the common factors, that gives 2 times x times y, or 2xy, and that gives the GCF, 2xy. Now you want to arrange the GCF so it's on the outside of the parentheses and keep the structure of what you were given to start with. We started out with one term added to another term, and that goes inside the parentheses. 2xy goes on the outside where the GCF is, and then you have to divide out the 2xy from each term. But that's kind of easy when you look back at what you originally had. 2 times x times y leaves just x for that term. In the other term, let's see what gets left behind. Looks like a 2 got left behind, so that goes here. Now to see whether or not we've got our answer all factored. Is 2xy times x plus 2 our answer? And what we can do is check our answer by multiplying it back in using the distributive property. So if we multiply 2xy to x, we get 2x squared y. If you multiply 2xy to 2, you get 4xy, which is exactly what we started with. So we do know that our answer, 2xy times x plus 2, is the right answer. Let's look at another example. Number 2, factor 36u to the 4th minus 9u to the 3rd minus 9u squared. Each term has factors. Break down each of the 3 terms into its factors. I can see that 9 is in common, and so I'll use that. And what's the greatest common factor in all 3 terms? Well, we can see if we circle 9, yep, all those are in common. And then we start with the u's, and we've got one u, and then you've got another u. And that's all I can say is in common in all 3 terms. So that must be the GCF, and 9 times u makes 9u squared. So our GCF is 9u squared. Now remember how to structure this, so the GCF is on the outside, and you just maintain the same type of terms that were given to you with the plus and minus in between. We had 2 minuses, we have 3 terms, so we leave that structure there. So we put the GCF on the outside, and then we figure out what is left behind after we pull out 9u squared from each of our terms. Looking at the first term, it looks like a 4 is left behind, as well as 2 u's, and so let's write 4u squared. Now in the second term, one of the u's was left behind, so we'll put that in the second spot. And in the third term, everything got taken out and 9u squared, but we have to hold that term. And remember that when we distribute it back in, we still have to get the original problem, so we hold the spot with the number 1. And let's check our answer, and we do that by using the distributive property. And let me write out what I think is the answer. And now let's use the distributive property and multiply 9u squared to 4u squared. Yep, we get 36u to the 4th. And then 9u squared times u would be 9u to the 3rd, and finally 9u squared times 1, and we would have 9u squared. Does it check out? Is that what you originally had as a problem? It does, and so you know that this is the factored form. Let's look at our third and final example. I want to factor this polynomial. We'll start with inspecting the coefficients of each of the three terms, 32, 8, and 64. What is the largest number that divides all three numbers? The greatest common factor is that number, and 8 divides all three numbers. Next, we want to look at a, the variable a, and looking at each of these three terms, we're looking at finding the common factor of a to the fifth, a to the fourth, and a to the third. Now think of it this way. What power of a divides all three of these? And the greatest power that you can divide all three with is a to the third. And finally, let's look at the b's. And you have b squared, and b squared. So that one, the greatest common factor is b squared. Now all three of these together then comprise the GCF. We'll place the GCF on the outside of the parentheses, maintaining the structure of what we were given. So I'll write here 8a to the third b squared, and then figure out what am I putting in for each of these blanks that hold the place of the terms. So let's divide 8 into 32 and you get 4. A to the third, let's see, I've got 2 a's left behind, and b squared, I took them all out. So I've got 4a squared for my first term. The second term, I took 8 out completely, but I have a left behind. B squared got all taken. And then 8 times what makes 64? That would be 8. The a to the third got all taken out, and so did the b squared. My final answer will be 8a to the third b squared times 4a squared minus a plus 8. And you can always check your result by multiplying it back through one at a time using the distributive property, and then you do get the original after you multiply that out. So we have our final answer. This is the factored form for the polynomial. Great, you've just seen 3 examples. I hope that helps. This is GCF factoring. Thanks a lot for watching. See you next time for great math videos.